Hi and welcome back. So we'll conclude today's lesson with a brief summary of the move constructor and then the move assignment operators implementation, and then we'll get into a couple of additional considerations because we've only really looked at move semantics through kind of the perspective of invoking them explicitly, when in reality, these functions can be, special functions can be invoked implicitly as well. So our move constructor is a parameterized constructor. So by definition, it will return nothing and its member and its name is going to be that of the class name. The parameter is something new, which we introduced within this lesson, an R value reference to the source object of the same type. Now the implementation for the move constructor is going to consist of two steps. The first being to create a shallow copy of the source, which will result in resource sharing with the source object as well as the object being constructed. The next step is to go ahead and break that shared relationship to the resource by updating the source to reflect its pilfered state. Now the move assignment operator is going to, how we're kind of crafting it, it has some similar components to our copy assignment operator. It's going to return a self-reference, the member function name within our class definition is going to be operator equal. And here's where we have one point of divergence. The parameter is going to be an R value reference to the source object of the same type. Now the move implementation or the move policy for our move assignment operator is going to be first to check the self assignment for the same reasons that we did so when implementing our copy assignment operator. Next is going to be to deallocate memory for the old dynamically allocated object on the left-hand side of the assignment expression. Now remember that the reason for this is we have the case where both parties involved in the assignment have potential to own their own resources. And since we're transferring the resource from the object presenting on the right-hand side to that on the left, we need to deallocate any old dynamically allocated objects associated with the object on the left-hand side. Thereafter, we can go ahead and perform a shallow copy of the source, and then we need to go ahead and update the source to reflect its pilfered state, in that we transferred its resources to the object on the left-hand side of our expression. And then, as with any sort of assignment operator that we've defined today, we'll return a self-reference to the object invoking this function. So a couple of additional considerations. We explored move semantics from the perspective of explicit ownership transfers. Move semantics also make it possible for compilers to implicitly replace expensive copy operations with less expensive moves. For instance, a compiler can recognize when a temporary object is being used, say during initialization and in assignment operations. In these cases, the compiler would employ move semantics provided you've defined them instead of the more expensive copy semantics. Compilers these days do get creative, so you might not observe a move operation when you expect one. For example, in return value optimization, RVO, the return value is constructed directly into the return value location, avoiding the need to perform any sort of move or copy operation, which is pretty cool. But understand that once we've defined move semantics for objects of the type, it's not only us who are going to be using them, but the compiler will also invoke them in various cases to provide a more efficient execution. So with that, I hope today's lesson was beneficial. I hope move semantics are rather clear. And we're going to slowly get into smart pointers here. As we move forward into the week, we'll get into just kind of an introduction as to what they are. And then we'll talk about unique pointers, where we'll really kind of get into this idea of resource ownership, and we'll actually restrict any sort of ability to copy the resources. So that'll be cool, and we'll get to that soon. So till then, I'll see you all tomorrow.